Hello everyone, and welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go through another example of a 3x3 matrix. So what I want to do is I want to give ourselves the matrix A here. And I want to set A to be equal to 3, 6, 7, 0, 2, 1, 3, -1, 1. Okay, so this is our new matrix here, and I want to figure out what's the determinant of A. Oop. Right, what's the determinant of A? So again, if we think back to our previous video where we said that the determinant of any n by n matrix, that's any square matrix, right, is going to be equal to the cofactor expansion along any row or any column. We now can calculate the determinant of this. And so what I would recommend doing is I would recommend looking and seeing what row or column has the most zeros. I'm going to make sort of a note here. Right, look for the row or column with the most zeros. Okay. So let's go ahead and take a look here. I'm going to choose, just because I see this 0 here, I'm going to go ahead and choose this first column here. So this is going to be the cofactor expansion I'm going to work from. So to sort of make note of that, right, we're doing the cofactor expansion along, we'll say on the first column. Okay, so just to sort of reiterate what this looks like, we're going to go through this slowly again. Right, cofactor expansion, right, on the first column, that's going to be the value of the first row, first column, times the cofactor of the first row, first column, plus the value of the second row, first column, times the cofactor of the second row, first column, plus the value of the third row, first column, times the cofactor of the third row, first column. Right? So all I've done here is I've just set up the equation for the cofactor expansion of the first column. So go ahead and plug things in here. So this is going to be 3 times -1 raised to the 1 plus 1 times the determinant of the matrix that results from ignoring the first row and the first column. So that's going to be 2, 1, -1, 1. And then we're going to add to that the value of the second row first column, which is going to be this 0 here, times the cofactor expansion that we get from ignoring this column, or this row and this column, which is going to be 6, 7, -1, 1, and then times -1 raised to the 2 plus 1. That's 2 plus 1. Okay. Then we're finally adding to that the value of row 3, column 1, which is the 3 here, times -1 raised to the 3 plus 1 times the determinant of the matrix minor obtained by ignoring this row and this column. So that's going to be 6, 7, 2, 1. Again, all I've done is just put the values in for this for this equation here. So now again, we're going to go back to that equation. We're going to go back to that equation for the determinant of a 2 by 2 matrix, which is AD minus BC, which we can use to calculate the determinants for all of those. Okay, so if we apply that equation and we sort of think through steps here, we can begin to plug things in for this for these equations. So this is going to be 3. Oops, let's switch back to white. Okay, so this is going to be 3 times negative 1 to the second power is going to be 1. And the determinant of this matrix, right, 2, 1, negative 1, 1, the determinant of that matrix is going to be 3. So we have a 3 there. Now this one, right, because we have a 0 out here, we actually don't even have to bother doing it, because this whole thing, no matter what the determinant is going to just equate to 0, so we can put a 0 there. Again, I don't want to lose you here. I want to repeat what I just said. All right, because the value, right, because the value here is 0, no matter what we get for the determinant cofactor, all right, that's just a 0, so we don't have to do anything else. We can just stop and call that 0. Now this is going to be 3 times negative 1 to the 4th is 1 times the determinant here is going to be negative 8. And again, if I'm going too fast for this calculation, pause the video and you can double check me if you don't believe me or if you think something seems weird. Just double check where I'm using AD minus BC on these 2 by 2 matrices to get the determinant. So 3 times 1 times 3, we get 9, plus, we already said this was 0, we didn't have to do anything, plus 3 times 1 is 3, times negative 8 is negative 24. So if we do that, 9 plus negative 24, we get negative 15. So this negative 15 right here, this is our determinant of this 3 by 3 matrix. So again, hopefully that made sense. If you have any questions, please reach out. Thank you.